Okay, so in this next video, we're going to start a second half of section 8.6, which is radical functions, and we're actually going to be finding inverses of radical functions, so that we deals with interchanging x and y. Then we're going to go ahead and graph those. So we look here, we want to find the inverse of the function and then graph the function and its inverse. One of the things that might be helpful here is some of the previous topics we've considered are completing the square. So that may be something that you have to work with in order to find the inverse. But the general idea is we need to switch x and y. Switching x and y will allow us to find the inverse. I'm going to find the inverse and then graph the function and its inverse. The first thing I'm going to do is I'm going to graph the function, which I'm going to put in black. So it's y is equal to 2 minus x squared. So if I have y is equal to 2 minus x squared, I can go ahead and find my zeros. 1, I know it opens down. And negative x squared is equal to negative 2. X squared is equal to 2. Take the square roots. I get x is equal to plus or minus the square root of 2. So that's going to go ahead and give me my zeros in kind of a general shape. So my zeros are at root 2 and negative root 2. So I'm going to go ahead and plot these. That's about 1.7. So I'm going to go ahead and try and get a good job of 1.7. We'll just kind of put it at 2. And the 0 is in the middle, so we know we're actually symmetric at the y-axis. So here's this guy right here. And so that, and I apologize, it was graphed in black, graphed it in blue. So now what we're going to do is we're going to find the inverse and then graph that guy. So if I want to find the inverse, the good old switch x and y and solve is going to work. So let's go ahead and find the inverse. So here's my work for that. So I'm going to go ahead and switch x and y, and then I'm going to solve for y. And some are easier than others. This one's a pretty straightforward one. Divide out a negative. So if I divide a negative 1 out, I divide this whole thing by negative 1, and I'm going to get a negative x plus 2 is equal to y squared. Then I am going to take the square root of both sides. The biggest deal here is do not forget to put in that plus or minus when you go ahead and find the inverse. So a couple things here. We've discussed in our previous video, if I find the 0, I can go ahead and plot it. So in graphing its inverse, I could do one of two things. I mean, you'll have a calculator for this, but I'm going to do it without a calculator because it's easy to plug this stuff in. I'm going to go ahead and look at this piece right here, and negative x is equal to negative 2, x is equal to 2. That's my 0. So in red, I'm going to go ahead and plot my 0. And now the negative in front right here I got a duplicate here, so let me see if I can undo. That didn't work. Sorry about that. So I got this one. We'll scratch that one out. Sorry about that. I got this negative here, which means it's going to reflect over the y-axis, which means I have this generic shape, and it's going to go like this. I also have a negative one. That's a positive one. I have a negative one, which causes it to reflect down. So by using these transformations that we've talked about in previous chapters, it allows me to graph my shape. So there's a couple things that we need to consider. One is, notice the similarities. The parabola opens down in a negative direction. So the inverse is going to open left or right. Well, because the parabola opens down, this one's going to open left. They're both going in a negative direction. Notice the coordinates of the vertices. This is, or the vertex. This one is 2, 0. This one is 0, 2. The idea of just switching x and y, we can do that with our points also, and that helps us determine our graph. So we did it algebraically. Graphically, you can use your graphing calculators, but knowing that just x's and y's switch, you can pick a couple points and just switch those guys, plot them, know the direction that you're ending in, and that's how we can graph an inverse function of a parabola.